Dear all, a very warm welcome to the Havells Insignia Presents ADEX, a series by Realty Plus Masterclass. For all those who are joining us for the first time, friends, ADEX Talks is a unique initiative dedicated to facilitate the development of an ecosystem for world-class designers in India. The one-of-a-kind architecture and design talk show aims to enable the process of collaboration with the best in the industry so as to position architects, designers, and manufacturers as partners offering complete solutions. I'm Sapna Srivastava, editor Realty Plus magazine, and let's begin with a brief introduction of Realty Plus. Can we have the AV, please?
Some people are born to show the world which path to choose in a crisis. Some brands are born to do the same. And during the times of challenge, the stalwarts of Indian real estate industry have chosen to do just that by showing others the way to finding opportunities even amidst a crisis. By showing the world how to go about delivering on promises even amidst adversity. Success doesn't just happen, it happens by design, by pushing the boundaries, by raising the bar. It's days of creating a vision and nights of bringing it to life. Knowing that pictures are worth 1,000 words and every word makes a difference. It's doing the research, trusting your instinct and finishing what you started. For the past 17 years, Realty Plus has been turning obstacles into opportunities, keeping the industry informed on the latest developments. Innovating to inspire debate and discussion. Bringing forth the perspectives of industry leaders. Honoring hard work and achievement. Keeping the industry connected. This is what we are built on. This is what we are building. We are Realty Plus and we lead the way.
So this was a brief snippet of what Realty Plus is, its products and its initiatives. To know more about Realty Plus, do get in touch with Ms. Tripti Kedia, publisher and business head at Realty Plus. And now, moving on to the program of the day, I welcome Mr. Vivek Yadav, Senior Vice President, Havells India Limited, to share his views on the ADEX series presented by Havells Insignia. But before that, let me give a brief introduction of Mr. Yadav. He's an industry veteran with over 31 years of experience in electrical and automation. Having worked in all domains from residential, commercial, industrial, and infrastructure, he has extensive experience in products and solutions from circuit protections in low voltage and medium voltage to automation in industries and homes. Mr. Yadav is currently heading Havells domestic circuit protection, electric wiring accessories, and home automation business, along with projects and enterprise business, which cuts across all business verticals in Havells. So, Mr. Yadav, a very warm welcome to you, and I hand it over to you for the welcome address.
Yeah, thank you, Sapna. Good afternoon, everyone, and thanks for joining on this webinar. I will speak a little bit more about ADEX, and I think before that, I would request the team to run an AV on Havells. Havells, as you know all, is a large company which is into various verticals and different products for the different market segments, ranging from residential to commercial to industry and infrastructure. In residential sector, we claim to have products which can occupy almost 75% of the plug points, socket points that we have inside homes. We have solutions for industry through our different businesses that we have in lighting, switchgear, consumer durables. All these we cover in the other market segments of the customer segments that we have. So let's see the AV, and this will give you more in-depth detail about what Havells is. And then after that, I'll talk about a little bit more on ADEX. Can we have the AV, please?
For more than 6 decades, Havells India Limited has been focusing on building a better future. A future where technology is used to drive progress, improve business outcomes, and create a better quality of life. Today, Havells stands tall in the FMEG sector as a major power distribution equipment manufacturer with a strong global footprint, owing to its innovative future-ready products for a wide spectrum of applications. With the acquisition of Lloyd in 2017, Havells has made a foray into high-potential consumer durable segment with offerings of air conditioners, LED televisions, washing machines, refrigerators and dishwashers. The new synergy further complements the brand's deeper into homes vision. Havells owns some of the most prestigious global brands like Crabtree, Lloyd, Standard and Rio. Its global network constitutes over 5,000 professionals across its offices. As part of its Make in India philosophy, Havells is manufacturing 97% of its products in-house. With 14 state-of-the-art, fully automated manufacturing plants located across India, Havells offers superior quality and globally benchmarked products to its customers. Havells has set up a large distribution network to set new benchmarks in prompt delivery and service to customers. Over 11,000 dealers, 150,000 retailers and 700 plus Havells Galaxy exclusive brand showrooms across the country are helping customers to choose from its wide range of products. Havells has a robust supply chain management system with 31 warehouses located pan-India. The meticulous forecasting and demand planning delivers seamless tracking system. Havells is the first FMEG company to offer doorstep service, offering a seamless post-purchase experience. It has the largest service network with 800 plus service points covering 441 towns 24/7 across India. Havells Center for Research and Innovation, CRI, at Noida, with a team of highly qualified engineers and designers, continuously work towards creating differentiated and innovative products while adhering to stringent quality norms at par with international standards. Havells products are certified by nationally accredited laboratories such as CPRI and ERDA. Havells has a strong in-house IT vertical which develops innovative technology platforms to support its robust service and supply chain management system. Growing together is ingrained in the ethos of Havells and has resulted in it launching many innovative and profitable schemes for its dealer community. Havells has strong credentials in B2B and large government projects as well, such as lighting up Kolkata railway station and partnering with NBCC India Limited to beautify and transform the night view of India's heritage monuments like Humayun's tomb, as it believes in the philosophy of spearheading the progress of the nation without ignoring the past. Havells has taken giant strides to create an innovative world full of possibilities, not only for itself, but also for all its channel partners and customers. With a commitment to improve people's lives and help create a better global society, Havells is inspiring the world and making a difference.
Okay. So let me talk a bit more about ADEX and the overarching program, which is called Havells Insignia. So we are bringing industry experts on this unique platform that we are creating, which is called Havells Insignia. And the objective is to engage and collaborate with each other. It is going to be an interactive platform where architects, designers, and consultants of repute from India and abroad will come together to share their thoughts, vision, expertise, and shared knowledge. And of course, most of it will be through a select invitation for a select club. It's going to be a unique initiative dedicated to facilitating the development of an ecosystem for world-class designers. And how we are going to do this, we have used a 4I framework, and which is incubation, interaction, influence, and innovation. So under each of these heads, we will create platforms. So ADEX is one such platform under the interaction category, where we are calling national and international repute designers who will come and share their experiences and expertise in these areas and enlighten all the audience that we invite from the industry. So next would be a yearbook that we are working on, which will highlight and commemorate achievements made in the industry by the leading specifiers. It will be an exclusive standout annual publication for cutting-edge design ideas, innovative viewpoints, which will set the agenda for the year for the design themes. It will also feature globally benchmarked works by leading specifiers across the globe and an ideal reference point for the budding architects and interior designers. We are also working on creating white papers, which will help educate audience to bring to light a new or different perspective. It will also help to delve deeper into issues, trends, and policies related to residential and commercial infrastructure. And it will also have causes that experts feel strongly about and deep dive into their implications and benefits. The other area would be, contests. We could design contests amongst the budding architects, the experienced architects and designers. Something like redesigning a city, using ruins to create monuments. So such kind of contests also would be coming henceforth in near future. We would also be rewarding the best in the industry, the best amongst the specifiers through awards. And the aim will be to honor and celebrate and share the very best projects in the field of architectural design, interior design, and landscape architecture. So these are some of the highlights of the program. Today's program, which is the ADEX series, we've already had a few international designers of repute. And last episode was featuring an Indian designer. And today we are coming up with a new Indian designer, not new, but on this platform, new Indian designer. And we are very happy that this platform is gaining momentum and is being appreciated by one and all. So let's take this program today forward, and I hand over back to Sapna for this.
Thanks, Mr. Vivek Yadav, for sharing that brief on various Havells initiatives, the 4 I's, as you mentioned, and including this very, first of its kind design talk show series that we have going here, and also for setting the tone of the day. And as you rightly mentioned, let's bring on stage the star of the day, the eminent architect who is joining for this episode, Mr. Manit Rastogi, founding partner, Morphogenesis. As we know, he does not need any introduction, but still let me, as a formality, give a brief intro of architect Manit Rastogi. He's an internationally renowned architect, and he co-founded Morphogenesis in the year 1996, along with his partner Sonali Rastogi. Morphogenesis is one of the largest architectural firms in India, as we all know, and it is also listed among the top 100 architectural firms globally. He is a fellow of the Indian Institute of Architects, the Royal Society of Arts, and a chartered member of the Royal Institute of British Architects. As the founder member of the Griha Council, architect Manit Rastogi has been spearheading India's own green rating system. Manit has worked actively with urban policy makers to spearhead initiatives with an emphasis on environmental and socio-cultural sustainability. So without much delay, let's move on to the presentation by architect Manit Rastogi. Can we have the AV, please?
Good afternoon, everyone. I would like to begin by thanking Realty Plus and Havells for hosting this show. My today's talk is titled Reflections of Technology and Design. Technology is a much misunderstood word. Most people affiliate it with digital technologies, with advanced engineering. However, the definition of the term technology is the application of scientific knowledge to the betterment of the human environment or the human condition. And that's really what my today's talk is going to be, of how we have applied technology extensively towards building a sustainable and resilient architecture. So I'll demonstrate these various technologies or this scientific application that we have been pursuing for the last 25 years in our practice. And essentially that scientific application comes from plagiarizing from the past, from a plethora of 5,000 years of architecture of the region, and find contemporary ways of applying it in different climatic conditions, in different locations within India. And the interesting part about India is that it's extremely diverse.
India is one of the largest populations in the world, next to China. It's about 1.4 billion people. But urban India has all the sort of issues that large emerging nations have. It has water issues in our cities. Climate change has affected India tremendously. We've had some of the worst weather patterns in the last year or so. We've had issues with energy. We've had issues with pollution. And some of this led to a lot of our early thinking why we would pursue the whole sort of genre of sustainable design and see if architecture, if buildings, the whole built environment can help resolve what our politicians and what our cities over the years have not been able to do. So very early on, we sort of looked at what's really the issue with energy. And we did this study about a couple of decades back. At that time, India's population was 1.2 billion and now it's about 1.4 billion. And just very broadly speaking, in terms of the fact that India has a daily solar radiation, which is on an average 5.5 kilowatt hours per square meter of the country's mass. We only really need 0.003% of this land mass if we were to just drive our entire energy by solar. It's actually nothing. It's only 2% of the wasteland, the deserts of India, is all that we would need to drive all the energy, not for today's requirement, for what is projected for 2050. And then the second part was water. And if we just look at the annual rainfall, I know this is very macro level data, but it laid the context of what we would do at a micro level, given the fact that energy wasn't a problem, but it is. Water isn't a problem. 2% of the rainfall in India, if harvested, would suffice 150 liters a person, for 1.4 billion people. And so what are we really doing? And we were sort of, looking at our cities and we were looking at our buildings, and we had developed this sort of system where our buildings would consume energy and they would consume water and they would generate waste, and it was a one-way flow. What you see on the top here is through this process of sustainability, where our main aim has been to push our projects to net zero energy, net zero water, fresh water, and net zero waste to landfill. Optimization has been mostly about how do you build less? How do you do a lot more with a lot less? And essentially that's about removing embodied energy, and that's about reducing CO2 emissions from how you build something. Uniqueness is about, again, a set of metrics which looks at tradition, heritage, and culture. And that third philosophy and third arm grows from the fact that across India, given the fact that price points of construction are extremely frugal, everything started looking the same. It didn't matter whether you were in a cold climate, in a temperate climate, in a hot climate, in a warm, humid climate. But by and large, most buildings and everything started looking the same. And that's because they were adopting processes of construction and design that allowed for that to happen. And And we found ways of digging into the past to find ways to build the future. And that's where we sort of got the unique. And livability was essentially about engaging not only the client and the end user of our buildings, but trying to engage the people who built that building. Now, CO2 emission and fresh water, this is all benchmarked to the ECBC, the Energy Conservation Building Code of India, which is like a green building standard. And based on that, those standards, all our buildings are under post-occupancy evaluation. And we keep a track of those numbers, of what these buildings are achieving today. But that's over 2.5 decades. So I'll start with the first project. And this project dates back about nearly a decade or so. It's called the Pearl Academy. It sits in Jaipur. Jaipur is in Rajasthan and it sits in a desert climate. There were many challenges to this project. The first, of course, was the fact that cost. Now, I'm sure a lot of people here don't know, may not be familiar with cost of construction, but this project was built at $200 a square meter with all interiors and all the energy infrastructure, everything all told, which was virtually impossible in that time. And of course, a climate like Jaipur, which goes up to 48, 49 degrees Celsius in the summer, but can drop to close to zero in the nights in winter. And we began thinking about how we are sort of going to be able to build this building. And the first thing that came to our head was to throw out the air conditioning. Because you throw out the air conditioning, along with that, you reduce all the electrical equipment, but more so, you reduce the fact that the power generation is also done locally. So you have these diesel generating sets that generate that power, and you get rid of that as well. And we studied a lot of the traditional architecture. We used computational models to understand how do step wells work, why are they cooler in at the bottom than the top. We understood evaporative cooling, jalis, ventilation, shading. So we mapped out 200-kilometer radius. We said every material that we will use will come from that, because transportation costs are extremely heavy. And the other thing that we discovered at the time was that the temperature of the Earth about 3 meters below the surface is equal to the average temperature of the region. And in Jaipur, like I said, which goes from 0 to 48, 49 degrees, the average was sort of floating around 25. And we said, hey, that's a very useful, and which is why the step wells, if anyone has visited India and they go to the step well and you come down, it naturally feels cooler because the earth banking along with evaporative cooling is a phenomenal cooling mechanism. It's an underground air conditioner, naturally driven. So we said, fine. Now, typically speaking, any institutional building in India would be built as a block, and then you would sort of have the open space, which is the recreation space. But when you're in a desert climate, that open space is really worth nothing. And these large outdoor spaces become mostly unusable through the year. And we said, well, we won't do our building vertically. We'll spread our building out and use the whole building as a shade, like a tree. And therefore, the space under the building will become viable. We did a very optimized, simple rectangular form. Idea was again to decrease the amount of surface area that we exposed to getting heat gain. And we went through a series of courtyard morphologies. The idea really being to keep the sun out, but let the daylight in. I'm not going to show you these diagrams. All of you probably know them very, very well. But the idea really was to develop, and because it was a design and fashion school, the emotional element was that if you were inside this sort of very rigid form, which was driven by our environmental criteria, in any courtyard, the courtyard should not be sort of like a rectangle and it flows. It should sort of flow freely like a Mobius strip. And that was sort of the model when we began over about a decade back. To achieve the parameters of, without air conditioning in a desert climate, we sunk down 3 meters. We recycle all the rainwater and we recycle water from the toilets by filtering and using a treatment plant. And we created our own step well, Bavli, in effect, which allowed for evaporation through the courtyards and cooling the building internally. And that sort of negative space, if I may, was pulled out of the program. So we were supposed to build about 25,000 square meters. We did. We built about 2/3 of that. And that entire area underneath, which to date operates at about 28, 29 degrees Celsius naturally, is used for an outdoor cafeteria, is used for various functions, performances, etc. And that whole underbelly section was designed to do that. These are just some of the pictures of that sort of step well that we created. All the water is harvested, not a single drop of water leaves the site. But we were just trying to do, just work with limited resources effectively. And obviously the whole thing sits in shade, it catches the wind flows and it cools the building down. We looked at insulation. Insulation was very critical for a project like this in a desert climate. And there was a local community that made pots. We couldn't afford the sort of very expensive 50 mil glass wool or rock wool insulation. And we thought that pots, which were used traditionally, would make for great insulation, but air is a great insulator. And we use these inverted pots with a layer of screed on the top, and we use that for insulation. The pots were made on site by this local potter community. For the external skin, we kept our window-to-wall ratios very, very optimized. We are at about I think 20 or 25%, providing adequate daylight. And we created this buffer space, which is essentially a service space and a screen. And the screen is made from, again, a set of local community who make cement concrete jalis on a very simple system. And we ran all our services on the outside. So the screen allowed for the fact that the entire windows go blinds free, and the design of the screen changes based on the orientation. And all the services are openly accessible. The sprinklers run here. We use the sprinklers as a facade cleaning system, because once a month they are supposed to test and flush it. So that sort of cleans that up. And that's the building when it was finished about a decade back. So all the materials, the stone, everything here was from within a 200-kilometer radius. We did achieve the price point. And this building went on to become very popular with various schools of architecture. They've gone and studied it. We've had students from various programs in masters programs studying sustainable design, recording temperatures and seeing it. And for the last decade or so, it is sort of consistently in the summers, when external temperatures have hit 47, it's hit 29 degrees inside without air conditioning. It runs on an energy performance index of about 25 to date. Very simply, we get the bill that just divided out. And whilst it was being built, it gave a certain level of employment to the local community. And that gave us a lot of inspiration. And we thought that, if it was possible to get an 18 degrees delta by passive design, and it was possible to create something in these sort of kind of price points pushed by the adversity of price, then what is it that we could do as we moved on? And that's when we started sort of putting more formal metrics. And which is why I'll jump to a very different kind of building, which is the British School, which is in Delhi. That's a composite climate. And here budget was not an issue. And our brief was, to begin with, because it was the British School, was that they wanted it to be centrally air conditioned. All British schools pretty much across the world are either centrally heated or centrally air conditioned. And we argued the fact that if we can begin to achieve as much as we can naturally, then we will do so. And this project is about, I think, 6 or 7 years ago. And we then spoke to the clients, which was essentially the High Commissioner and the board. And we said that, why don't we look at this 5-acre site and generate, try and do India's first net zero energy, net zero water, net zero landfill, waste to landfill kind of building. And I said, fine, let's give it a shot. And so we did the math on the water, and from the 5 acres of land that we had, I'm not going to go through the calculations, but we could support a population of about 1,300 students. And we said, we'll do this in reverse. We said, so the notion of carrying capacity comes from the fact that what the land can afford in terms of water and energy is all that we will build. And 1,300 students worked very well for them. Now you can't. Now the problem with a city like Delhi is all our rain is concentrated in 3 months. So you can't store that much water for the rest of the year. So what you do is you dig down and you find an aquifer that's pure, and you use that as an underground tank, and you use that as an exchange. So you put water back into it and you pull it out of it. And over the year, you go net zero on water for 1,300 people. We took the same 1,300 people, and then we went about this, building out how much, because we needed to build about 20,000 square meters for fitting out an IB school. And we were trying to work out what is the correct ratio of rooftop solar to number of levels that we would need to be able to get to net zero, and therefore what would be the target EPI that we need to achieve. And after a lot of to and fro, we came to a 4-story building with a target energy performance index of 56 kilowatt hours per square meter a year. Now that number would by necessity drive a lot of passive design, where a lot of the heat loads and a lot of the lighting loads would need to disappear. And that's when we would be able to be net zero on water, net zero on energy. And again, we looked at a lot of, in Delhi, there's a very old city called Shahjahanabad. We looked at how those morphologies worked, how some of the earth banking worked. The other also key area was safety and security. And because we were propagating the idea of having open corridors, and we were not doubly loaded and had them air conditioned, the issue of security, CCTV cameras, and we came up with this idea. We didn't come up. We studied this idea of eyes everywhere. And if you look at any old vernacular evolution of any city anywhere in the world, where there was, in those days when there was no police several hundred years back or CCTV cameras, the cities were designed in a way that there were eyes everywhere. And that really was a security. So a combination of the two factors, we began to look at morphologies where we would be able to get eyes everywhere, step terraces, shaded courts, and we sort of landed up with this sort of model with a rooftop area sufficient to make this into a net zero energy project. Some other small things that we did, we put the labs on the top because the labs are constantly mechanically ventilated because of the fumes, and that automatically creates a buffer for everything underneath. We created natural voids for the wind flows to allow for the courtyards to function properly. And because of the orientation of the site, where we had pushed that form again from like we done earlier, we began to look at the Jali formation. Most of our teaching areas were on the northeast and the northwest, while the southwest was essentially a large screen just shading out the courtyards. A lot of this was built on site, so we came up with this sort of construction methodology of again full windows and having a secondary screen. The screen, of course, varies its opacity and density based on what's behind it and what orientation it works to. And yes, and that's sort of now the completed building. We did a lot of modeling for. So we had the classroom, and that was built. That was done perfectly, but to us, what was more important was to be able to create enough open spaces within which would be comfortable through the year. And we were targeting a delta of about 8 to 10 degrees in perceptible temperature in the outdoor areas in the school as compared to the external temperature. And then here's that project. So that's the front screen that shades off the southwest and sort of creates a full microclimate behind. Again, open corridors. What you see here are air filters because it was a British school. We didn't air condition the entire school, but we did for the classrooms we did, and then create these sort of passive spaces. A lot of outdoor spaces. Now, well, this is a bit old, but the trees are grown now. Yeah, and that's the school. Now, on our post-occupancy, we to date have an EPI of 52. It's the only school in India right now which got a GRIHA 5-star rating. GRIHA is India's own green rating system. And as I am a founding member of the green rating system for, I can say that I had, it is genuine. I didn't falsify any data. But it's operating at a 52. Now, what you see here is a combination of surface temperature and air temperature. So, and then we sort of map that back to perceptible temperature. So at a 44 outside, we did manage to get a 10 to 12 degree delta in all the open spaces inside that school. So to date, and we keep our classrooms at about 26 to 28 degrees. So there is a gradation as one steps out and moves through this entire project. And it operates today as a net zero on all accounts. So that was in that sort of composite sort of climate. I mean, like in a composite climate, the winters aren't a problem. The real problems are, and it's not even the summer, because shade, thermal mass, screens, a bit of evaporative cooling, that works. The real problem has always been the monsoon. Why it works really well in schools is that Indian schools are shut in the monsoons. That's the holiday period, and that sort of works really, really well, which doesn't in other kinds of typologies like offices or residential and which sort of brings me to this third one. This is a campus. It's a 100-acre campus for a very large technology ID firm called Wipro. They're amongst the 3 largest listed companies in India. And they do these sort of really massive campuses, have tens of thousands of people working there. This is located in Hyderabad, in Telangana. It's a very strange sort of climate. It's not very adverse, but it's got a tremendous amount of diffuse radiation. It barely has no cloud cover pretty much through the year, and temperatures do go up, but it's not that high. And it has reasonable wind speeds, reasonable wind temperatures, but the glare is just incredibly high. The diffuse radiation is what pushes temperatures up. And we worked on this project with TransSolar. It's one of the several we've done with them. And this is where we began. So we looked at the site, and that's about 100 acres. It's divided into 3 zones. And that zone 2, as we discovered, was largely unbuildable because it sat in a radius from a lake which wasn't too far away. And even as we discovered, it's sort of a bit low-lying. And the really buildable areas were these 2. We again pursued the idea of a carrying capacity. We had the 100 acres, and we worked out backwards as to how many people can we support from the rainfall. And we then, to store that water, because, like I said, Hyderabad is very strange in the sense that its entire geology is slate rock. So it was very hard to get to an aquifer and do water exchange with. So we really had to build a reservoir. So at a 4-meter depth, we needed about 15 acres of water reservoir to support 15,000 people working there. And again, similarly with energy, we worked out that if we hit a 60 EPI, then we will be able to, with 15 acres of a solar farm, which we have planned over and above the water reservoir. So essentially, the solar farm shades the water from evaporation and picks up the energy. We will be net zero on both accounts. And that's what we really did. So we identified the low-lying area. Everything slopes there. We got the natural rainwater. It's a 15-acre lake, about 4 meters deep. And then it's sort of got the solar panels that sit on top of it and on the site and shade it. And that piece of the land will never get overshadowed. So we could do the solar farm, 15 acres on the site itself. And that sort of set up the basis of the first series of master plan. The second exercise was, as I'll just go back, was how do we begin to hit a 60 kilowatt hours per square meter per year, of which 25 is on primary energy, which is lighting and air conditioning or ventilation, and the 35 is on equipment. And how do we begin to get our building to work with the 25? The 35 was a given, so that's all internal equipment. The question really was, how do we work to 100% daylighting on the floor plate, and how do we bring our air conditioning requirements down to a point where through the year, and to remind you, these buildings tend to operate about 10 to 12 hours a day, 365 days a year, because they're essentially very large tech companies. So we began this exercise where we did about 8 of them. We did many more, but we sort of isolated 8 morphologies which were built upon isolated single towers, a series of square towers, courtyards, a hybrid of the tower and the courtyard, mid-rise high density, low-rise high density, micro courtyards, and we came up with several morphologies heuristically, and then we began to test them. So various kinds of ground coverages, various heights, and we then put them through a series of analysis. So the first analysis that we did was, of course, for wind, because wind was critical for us to, if we were to hit that 60 EPI, which is 25, we also needed to be able to get a lot of the functions from inside the building out. And a lot of the functions to run passively without air conditioning. Of course, where the essential work was happening would be air conditioned for various reasons of, their data centers, they need very tight control on air conditioning, etc. But how much of this could be and for that we needed the wind. Now, predominantly Hyderabad had an east-west wind, and we put all these various forms. We selected 5 that performed reasonably well. We then put them through the horizontal plane. We were trying to look at what, in terms of seasonal solar radiation, would the insolation be on the lower planes, and basis that we picked up a certain scheme. We then looked at daylight autonomy for each of these 8 or 9 different schemes, and then again began to identify. And this was a highly iterative exercise between wind, solar radiation in the open spaces, and daylighting within the internal spaces, and what morphology would suit it the best. And finally, we selected the option which was sort of the micro courtyard option. And after doing a series of CFD runs on it, we cleaned up the entire the model. Again, this was highly iterative. And if anyone is very good with algorithms, this is a great one for that kind of process. And then we sort of finally ended up. So the first phase is what is now under construction, which I'll take you through. And then we've already done the urban design for the remaining 3, so that in a sense, the wind flows, the evaporative cooling, the shading, all those parameters remain the same. Coming to that first phase, which is approximately about 1 million square feet, about 100,000 square meters. We began looking at the outdoor spaces, and we went through a series of analysis, looking at a combination of having no roof, no fans, no dry misting, and having only a roof, like a lightweight tensile roof, a combination of roofs and fans, plus dry misting. And we then did a cross analysis of the fact that what would be the financial savings vis-a-vis these spaces sat inside air-conditioned spaces. And that sort of led to this design, which I call a large desert cooler, very traditional large. Desert cooler is essentially what used to be there before air conditioners, a box with a fan, and you had these this sort of hay on the side where water ran down, cooled it and shoved it through. And so the entire plane, which sort of sits on an elevated podium, was designed for those wind flows and those outdoor spaces. And we worked with SBP. We got this sort of height with this sort of tensile roof in combination with Transolar and us, and we sort of got this entire outdoor space working in a way that it is comfortable through the year. So it's comfortable for rain, it's comfortable for the summer, it's comfortable for the winter. And by and large, this entire outdoor space now takes on primary functions. I won't spend too much time on the indoor spaces. We went through a similar exercise of looking at various kinds of mechanisms of how can we remove as much air conditioning from the inside, whether it's underfloor, with heat recovery, hybrids, low velocity fans, and came to an optimal solution. Again, a lot of this is very cost-based, but it's also but it's a combination of sustainability and cost. And of course, settling for the fact that a client agreed to an internal temperature of 28 degrees, which is very useful because, and it's actually correct, because external temperatures can go up to 38 to 40 degrees, and working out the whole system based around that. So when the project, when we finished the design, 56% of the area was in under air-conditioned space, but consuming about less than half the air conditioning. So typically speaking, in this region, a building would consume 250 square foot for 1 ton of air conditioning. This project is operating at about 650 square feet per 1 ton of air conditioning. So even though 56% of the spaces are air conditioned, they're consuming less than half. About 35% have been moved to natural ventilation. Now, when I say natural ventilation, and I say the third piece, which is shaded outdoor, all of these are achieving thermal comfort conditions through the year. Greater than 90% of thermal conditions through the year. So not only did we manage to get about 10% of that area outside, which is about nearly 10,000 square meters. So cafeteria, gym, recreation, library is in that outdoor shaded space that I was showing you. We have outdoor meeting rooms, which were removed from the inside area, and of course the rival plaza. And in the naturally vented spaces, we have various other functions. So effectively, only half the building is air conditioned. This typically would be at 100%. Okay, so dramatically different project. I mean, this sits in Kolkata, which is the extreme sort of the extreme east of India. It's got a warm, humid climate, extremely humid, and temperatures don't change very much through the year. It's very close to the sea, but it's also in some senses, the cradle of civilization. A lot of the first universities, the first art, knowledge, culture, music, a lot of that was born in this part of the world, in this city particularly, and we began looking at the site. Now I think the total area here is about 3 million square feet, if I'm not wrong. Yeah, about 300,000 square meters, and it's a 17-acre site. Now we did the math on this. We couldn't push this one to net zero because, like I mentioned earlier, any environment that is high humid, the city maintains a greater than 70% humidity pretty much through the year, and therefore in a mixed-use environment consisting of offices, hotel, conferencing, data centers, etc., the air conditioning was inevitable. However, what we started thinking about was what could we do in terms of the entire site, and therefore we set up a site plan where we could maximize the wind flows through the site. And all the buildings, what we did here was because Calcutta sits on a 22 degrees latitude, which is pretty much the tropics, but we tilted the buildings 22 degrees to pure north. And what that allowed us to do was essentially shade from one side. Because when the sun overshoots, you end up shading from two sides, and it led to a 25% reduction in solar exposure. We found this this very interesting. But every time you tilt a building towards the east from pure north, by the latitude the building sits at, it actually helps cut down it helps cut down solar exposure naturally, which helped reduce the amount of shading we had to put into the building in the first place. Then once we sort of had that sort of east-west axis, and we left a lot of cross axes as well, because we wanted a lot of natural ventilation. Wind speeds are not very high in Calcutta. They're at about 2.5 meters per second, but over the year, they changed direction. And which is why we sort of had to have this sort of thing sort of very free and as opposed to the previous one that I showed you, which was very fort-like, but very channeled. This had to be sort of very open and transparent. I'm going to go to the landscape design of how that sort of works with the wind flows. The second problem that we had was a lot of this was very large flow plates, 40, 50,000 square feet flow plates. And by and large, what happened to large flow plates traditionally in these kind of is that you get these sort of very deep 60 by 60 or 50 by 75 meter deep flow plates, and your daylighting drops to on a CDA or if you're doing daylight autonomy, or it drops to anywhere between 40 to 50%. And we took the same area and we changed the morphology of the building so that we could push that back to about 90 to 100%. And I mean, the point really about that is the fact that you don't really have to work with the form, which is a given. But if you go iterative, the same exercise allowed us to break this up into where we put our core and how the form sort of breaks up where we get 100% natural daylighting. So that was the sort of the final piece of design when we finished up, I think, about 2.5, 3 years back. It's been in construction ever since. So we then began to look at the fact that now that we had a microclimate on the site, as you can see, this all reasonably well shaded, it's well ventilated. We now started working with a lot of the local craftsmen. And that sort of goes to my earlier point about, how do we work with local communities? And we found a lot of this sort of tradition, art, knowledge, culture, and we brought that back. So culture and art gallery, naturally ventilated, naturally water protected, 17 acres of outdoor, if I may, an arts and crafts museum. We worked with a lot of the local art schools and the local craftsmen who had this incredible craft who make all these sort of sculptures. And we then used a lot of the traditions of Bengal, of Calcutta, and abstracted them into this sort of graphic artwork, which the artisans could work with. And we then started using the west and the east facades, because all our buildings were north-south, albeit turned 22 degrees, and started working with them into sort of creating this urban art form, where, of course, it provided great amounts of insulation, because they were just carving local stone, and we were working with that. And, of course, working with the local alphabet, and again, working with the stone. And coming up with this sort of 500 meter by about 100 meter long urban art facade. This is all west. And a lot of this sort of being crafted by local craftsmen. And again, on the other side, on the east as well. So that's the project, again, under construction, where a lot of this, again, is being done on site. And this we've done sort of as a very, very deliberate move in terms of trying to, these are dying communities. Craft communities are dying communities, and I think the more we work with them, the more we learn from them. They seem to have a better heuristic understanding of what we understand computationally, and this entire sort of 500 meter by 100 meter high urban facade is being put up by these local craftsmen, and eventually sort of leading to that on completion. So we managed to get in a very, very humid environment. We got an EPI of 43 by a lot of these measures. So we are 90% daylit, zero glare, which is critical because what you really don't want to do is draw the blinds if you get the glare and then switch the lights on and it all goes south. So glare free, 90% daylit, window to wall ratio at 25%. Our facade is at 1 watt per square foot, envelope load design. And of course, the entire site is fully ventilated. Then that's how we sort of managed to hit the 43 degrees. And even in a humid environment, we've got a 5-degree delta in perceptible temperature. So at a 36 degrees to a 31 with ventilation, it works really well, even when you went stand there on the site, even today. So that's it. Thank you very much.
Thanks, Architect Manit Rastogi, for sharing those very fine examples of combining passive design, advanced technologies, and even local craftsmanship, and for those, highlighting those very interesting facts and points about net zero buildings. So Mr. Vivek Yadav is also here with us. Mr. Vivek Yadav, you just saw how, design and technology has been combined in Architect Rastogi's projects. What do you have to say about combining these two things for sustainable and green buildings in India?
I think this question needs no answer now, because the entire presentation by Architect Manit Rastogi was centered around this, and how beautifully each and every project that he highlighted was using technology. And in the beginning, when he said, it's what is technology? I mean, it's you're putting science to use in creating buildings which are sustainable and even net zero buildings. So, I'm really impressed, and I'm quite sure, the audience which is listening would have got, huge inspiration, especially the designers who are there, huge inspiration from the entire presentation. But we as manufacturer, I mean, from our side, I mean, how we can assist in creating those structures is, by giving technical solutions which will aid the output which is desired by the architect. It could be in terms of supplying equipment which are, let's say, solar. It could be giving them lighting, though natural lighting is something which is, informed and most desirable. But then in areas where natural lighting is not possible to design, I mean, how we can give the effect of natural lighting inside a building using the lighting technologies we have currently today, which is, the circadian rhythm of the human body, how it perceives lighting from morning till the evening. I mean, those kind of, artificial lighting can be created inside. And of course, lighting has become very, very efficient today. And if you use automation along with it, with daylight harvesting, whenever daylight is available, how lighting can adjust, and give the same effect which is desired inside in terms of lux levels, etc., which are, more conducive to people who are using it, and they become more and more efficient. And of course, the electrical equipment, which makes the use of energy safer inside a building, convenient and safe, which is very, very important. And that electrical equipment not just saves people's lives and keeps the usage of energy safe, but also it is efficient and not producing enough producing heat, so that again it puts load on the air conditioning. So I think this is what I had to say, but the presentation speaks volumes about usage of technology and science in creating buildings which are natural, which is taking care of people who use and the societies around it. Beautiful. I really loved the presentation.
Thank you. So that's the whole idea of this, platform: manufacturers, architects, designers working together. Architect Rastogi, you made it look very easy and simple, designing complex buildings. But what are the challenges in building a complex and a modern building, as well as resource efficient, energy efficient?
Thank you, Vivek. Thank you, Sapna. A lot of the challenge lies in getting things first time right, in spending 11 hours to polish the axe and then 1 hour to cut the tree. And the objective of technology, of design thinking, of all the science that we've been discussing is to actually make the building simple. It's not to make it complicated. Building is an extremely complicated task. I mean, if you look at the difference between manufacturing, like say, like what Havells does, okay, they create one perfect product and then they spin out, thousands or hundreds of thousands of those. Unfortunately, with buildings, we make one at a time. You get that wrong, and and that's it. So there is no prototyping. There is no. So I think the real challenge comes in the fact that as designers working in tandem with manufacturers who obviously bring all it's their products that we essentially just weave together into a building. The real challenge really is to try and get as much of that thinking done as early as possible to ensure that we're not trying to do this on the fly when we're really making the building. So I mean, no manufacturer today would start out building a car and then sort of determine how it's going to perform. You do all your prototyping, your testing. There are many softwares available by which you can gauge performance of a building prior to even starting its construction. You can simulate daylight, you can simulate artificial light, you can simulate automation. So, so it's not really a challenge, but it's a recommendation to all my fellow architects out there and to my fellow clients and developers to spend as much time as possible in trying to get that performance right prior to commencing construction.
Okay, so spend more time on the drawing board before starting the execution, and that is where, and use advanced software, as you mentioned, a lot of places for analysis and simulation softwares. Given the pandemic, everyone is talking about how pandemic has changed people behavior, how pandemic has changed how people are now working and living. What are the changes you envisage as a designer in terms of office and residential spaces that we are going to see, or we are already seeing?
So if you look at the two biggest construction segments in India, one is residential, the other is commercial office. So in the residential segment, what we are beginning to see is the traditional model of Indian residential housing was that every space had a particular use. A bedroom, was for sleeping. Living room was for meeting together, socializing. A dining room was for eating. What we're now beginning to see that each space has now turned into a variety of uses. The bedroom is being used as a classroom in the day. It's being used as potentially as a yoga space in the early evening. It's being used to sleep at night. And each of these spaces have now moved away from one function to one space to multiple functions to the same space. And that in turn has its own challenges in design. How do you handle acoustics for a bedroom, which is a classroom, a yoga space, and a bedroom? How do you use a dining table for two people, like a co-working space during the day? And as we are we will be living in a world which is going to be more hybrid rather than I don't think we're going to go back 100%, but that also depends from industry to industry of going back of segregating work life and residential life. I think that overlap and that amorphousness between the two will coexist. So residential design will have to take on that challenge of how is a home, a school, an office, and a home at the same time. And the office space, what we are beginning to see is we spent the last 20 years densifying our offices. What we began with 20 years back would be an office where spatial allocation would be 200 square feet per person. And over 2 decades, that sort of compacted down to maybe 60, 70 square feet per person. So you're getting 3 times as many people in the same building that we were getting 2 decades back. And of course, that had to do with real estate costs and operation costs, etc. And now what we're beginning to see is a reverse trend. And we're seeing that that sort of shift away from over densification to hybrid models of work where you can de-densify the office, yet keep the same amount of workforce, but just ensure that the people who work from home versus people who are coming to office are compatible in a way that the space still works. What you're also beginning to see a lot of vertical transportation systems, say lifts, are not being allowed to be compacted as they used to be. You'd have lifts in the morning hours and evening hours full of people. Now, when you start cutting that down, it puts a different kind of pressure on the building in terms of moving people in and out. And we're having to design innovative movement systems within buildings to make sure that there's not that much congregation of people. We're having to bring food courts out into the open and make them comfortable, like I showed you in that in the project we're doing with Wipro. So there's a lot of integration of outside, inside, de-densification in the workplace that we're beginning to see. What we're also beginning to see is a lot of emphasis on air quality, and a natural sort of shift away from traditional systems of air conditioning, where the cold air comes from the top from a duct, but the return air also goes back up as well, and then there is that sort of intermixing. So we are now designing systems where the air comes from the bottom and is sucked out from the top. So there is no. So there is a lot of thrust, and new technologies are being evolved. So we're going beyond sustainability to health, safety, hygiene, wellness. That's what we're really seeing in the new workplace.
That's right. That's right. Vivek, would you like to add something here? Are these changes here to stay, or do you think it's going to be a short term, and maybe in a year or two we'll go back to the same ways of working and living?
I feel that some of the habits that we formed, they are here to stay, and it will be a mix of what we've started to do now, including work from home, and so it may not be fully back to what it was in terms of practices and the way we work, especially that may not come back fully to what it was pre-pandemic. Okay, I have a question, if you may allow, Sapna. So Manit, as manufacturers, we often have this dilemma about automation. We've been into automation for a long time, and we often find it difficult to convince end users mean developers who are creating buildings, and even specifiers to go in for automation for lighting or a lot of other areas. And it becomes often a big challenge to convince people around, because it always comes that cost is important when the building is being made, but the long-term view, a lot of people don't see. What are your views on this? Of course, it'll help us also to think about our portfolio and our business.
See, Vivek, the point is this. In our 2.5 decades of working in India, one thing that has always been paramount is cost. Okay, and nothing beats cost. And cost and profit are two words that you should not even attempt to surmount it. However, it's also a cultural issue. Now, if you look at 2.5 decades back when we were doing buildings, and commercial buildings were they were single glass and very low performance facades. And today, no one even talks about that. Doing a double glazed high performance facade is now the norm, as opposed to now. Why did that happen? That happened predominantly because of a rising consciousness amongst people that saving energy is really important, and sustainability is important, and of course climate change. There were many there was a lot of awareness that was brought about in the last couple of decades for people to do that. Now today, if you're working with a developer, whether the developer wants it or not, the tenant wants it. An MNC tenant will not walk into a building unless it's extremely unless the building can be measured and it can be managed in a certain way. Similarly, now when it comes to automation in homes, and I presume that I don't think we don't have any problem with automation in the office space, in the workplace. Right. And that's simply because of the fact that you don't have a Ramu running around trying to switch on and switch off lights. You need lights to come on based on the lux levels outside. You need them to switch off. You need occupancy sensors, right, and you need the whole system to work together. It's a larger space with lots of people. Mm-hmm. What happens in homes? So private houses, we have a lot of automation. We've got 5 people living in a 10,000, 20,000 square feet house. You've got evening settings, mood settings. You've got and because the spaces are large with many kinds of lighting types, it's virtually impossible to control without automation. But when it comes to the individual apartments, okay, that's where your challenge will come. So what we found successful there is that we insist that the system is enabled for the resident to put the automation in. But the wiring is it's like air conditioning. Sometimes in apartments, developers don't put the air conditioning, but they'll do the piping. They'll do the drain, they'll do the refrigerant piping, etc. And similarly with automation, what we recommend is put the wiring in place. Let the controllers be put by the tenant. So at least it has that option, and they don't have to go around chasing their work data. And more importantly is that today, when you have a multitude of spaces, if I could be in my bedroom and hit a little switches which said I'm now in a classroom mode, okay, where I'm on a screen, there should be no light that is falling on my screen, etc. But there's a bedroom mode in the evening where my lamps come on, and so I think you need to focus automation rather than only on controlling lights to these kind of moods which have become now prevalent in these multitude of spaces in residential apartments, because they're used differently through the day. Integrated to, of course, how the curtains or the blinds operate.
That's a very, very good input, and I think valid point, because when you sell automation, I think you have to sell use cases more rather than selling the equipment. I think that's really important. And we are seeing in the home front, we are seeing that people are opening up and they are asking for it. I'm talking because I have been in this industry for a long time, and I've seen those times when people did not know anything about automation, especially for home use. But now I think the awareness is far better, and people come and ask for it. So the use cases have been established, and you're right. So the focus has to be on how the automation is to be used in a particular situation, how it is going to help their life become more easier and comfortable inside homes. Right. Thank you.
Right.
That's a related question we have got is, Manit, you spoke about wellness, safety, and, well-being. The question is how advanced building materials can enhance human wellness in buildings. Do we have any examples how, if we use, automation is one where, for convenience and wellness, any other examples of products?
Of course, it's across the board, Sapna. It's a flooring materials that are easy to clean. You've got lighting. We've pretty much entirely moved to LED lighting as opposed to all the other various forms of lighting we used to have. Air conditioning systems or air conditioners that now are highly energy efficient, but at the same time have the right kind of filters to keep the indoor air quality better. We've got wall finishes, low VOC paints that don't leave out odors through the, for a year after occupying, which are highly toxic. There's a whole plethora of knowledge and of materials out there that are very amenable to wellness, hygiene, and well-being, and they're well documented. And a lot of the manufacturers do know this. And in fact, some of the green rating systems, whether it's IGBC, LEED, or REHAB, also rate these materials for whether are they really sustainable and all of that. But I think again it comes down to awareness. I mean, how much does the person who's buying an apartment, for example, in a residential complex know about that? And of course, as we know today, everything is driven by price. However, this is not a price issue. This is an awareness issue. They want it, they don't know how. And I think that's where a lot of what manufacturers will have to do, industry bodies will have to do, is to drive that awareness and that learning. We're one of the few countries in the world where in a K-12 syllabus, in a school syllabus, there is nothing to do with sustainability. There's nothing to do with design. It's very, very centered around a subject and its outcome. And until we begin changing things at an educative level, at the school level, where that thinking starts. Same thing with our university syllabuses. What we are talking about is once a person enters their professional life, and by then, trying to make a person unlearn and relearn is far more difficult than to seed it correctly to begin.
Right.
If children become conscious of the fact that if you leave a room, you switch the light off, because a switch is nothing more than saving the energy. Saving energy saves carbon. Saving carbon saves climate. It's just as simple as that. It's just ingraining those simple principles, and you'll see the outcome in a few years from now.
Okay, so catch them young.
Catch them young. Build it in culture.
Right, right.
Yeah, thanks. Sorry, Sapna, can I ask a question? Okay. One question, which is there in my mind, it's regarding, listening to customer. So it's often said that, you have to listen to your customer's voice, and, then you design your building, then you design your product. But there is also a view which, Steve Jobs used to say. He says, the customer doesn't know what he wants. So you have to give him, which could be his latent need. So when you design your product, when you design your buildings, I mean, how much of, you get customer's voice, and then how much of, you work on the design, and you know that, today, what I've heard from my customer, I mean, probably doesn't know what he needs. So do you think on those lines?
Vivek, the profession of architecture is not very different from the institution of marriage. When we get into a relationship with a client, and of course bring years of experience as well with it, we listen a lot, okay, but we also we learn from the client's experience, because they're the ones who've been who are actually dealing with the end users for the life cycle of the building. But at the same time, they learn from us as well. So the idea really is to set up this mutual relationship of cross learning. So all ideas are good ideas, put them on the table, but have a very structured way of analyzing each one and either accepting or eliminating in a very neutral environment. The problem, we found earlier on was it was mostly a clash of egos. Architect is saying this, and the client is saying that, and the engineers are saying this, and so we came up with a methodology, which we call integrated project delivery, where even before we went pen to paper, all the stakeholders are put on the same table. Whether it's from the client side, it could be their marketing people, it could be the engineering team, architects, consultants, if there are end users, contractors, we put everyone on the same table. And it's okay, let's work out what is the program, what are we trying to achieve? And then we go to the second part of how we do things, we call it metric-based design. Whatever we're trying to achieve, we put numbers. What is it that we want to do, which we can measure at the end of the project to know whether we failed or succeeded. And the idea really is this: it's cooperation versus competition. So if you stop competing and start cooperating and start sharing, a lot more happens. And we found that very successful.
Good. Thanks.
I think one of the examples that you mentioned was British school, where the client first wanted a fully air-conditioned building, but
Right.
after discussion, they went in for the net zero building. So that's one example that you mentioned. We have a lot of questions, but because of paucity of time, we'll take just one more question. Manit, this comes to you. What are the top 3 technologies that you feel will be at the forefront of design and construction in the coming times?
So, the top 3 technologies. Okay, one, what we do think is so right now there's a technology which is called digital twins. So you design the building and you take the digital twin of that building, put it in the cloud, and that carries information with it. However, what we would like to begin to see is the merging of 2 or 3, the convergence of 2 or 3 technologies. So if you look at drone technologies, if you look at surveillance technologies, now all buildings have CCTV cameras for security, but that's not really what we should be using them for. We don't design buildings for buildings, we design building for people. So if we can start mapping using the cameras, and we start using drones, and we start mapping how people are actually using the building, we will be able to address those needs far better. Now that technology already exists. It's just a question of getting 3 or 4 different technologies to talk to each other. That's one. So convergence. The second one that we think that we need desperately in India is to start manufacturing our buildings in combination with craft. Okay, so craft is something we're very high on, but you can't use craft to make big buildings. And the way that we're still making a lot of our buildings in India is the same technology that existed 500 years back. Okay, and what we really need to be able to do is I'll give you an example of a car again. Every part of a car is designed with a certain tolerance to fit a certain way, with a certain life cycle. If you look at a building, concrete is supposed to last 100 years, glass will last a certain period, the MEP equipment or the lights will die out in maybe 7 years, the system, you'll have change. It is very, very asynchronous. So the building today it's designed in a way that all the parts of the building are not in sync with each other in terms of the life cycle of the building. So in a country like India, where we have a lot to build, most of India hasn't been built as yet, we need to find newer methods of manufacturing our buildings, of making them, and moving away from our traditional methods of RCC construction and doing things on site, etc., etc. We have been moving in that direction, but hopefully we'll see a lot more in terms of construction technology going there. And third, of course, is design technologies. We see the emergence of design tools, which essentially will, so right now we work with about 8 different softwares to make a building, maybe more. Okay, and what we would really like, so the structural engineering design is done by a structural engineer with a separate software. We do the architectural design, we do the energy simulation, someone else does fluid dynamics, someone else does something else. Once all these come together, we'll be able to simultaneously analyze the performance of a building and design rather than having to do this sequentially across a multitude of people. And it is that convergence. So really, anything I see in the future of technology is the breaking down of boundaries between various fields and the convergence of all of this together. And the feedback loops, fundamentally important. Today the designer designs, goes away, the contractor builds, goes away, the end user uses the building ends its life. But to close those loops, and we need, and today we have the technology, it's a question of how we apply it. So it would be great if we can have that level of understanding in terms of how our buildings operate during their life cycle and close that loop. So 3 key areas. So manufacture your buildings, to integrate technologies to understand the performance of buildings by observing human behavior, and 3, feedback loops from the buildings that we build. And I think that should be, in my opinion, the thrust of where we should be going.
Okay, fantastic. So what architect Manit Rastogi is saying, technologies are there. What we need is convergence. What we need is integration of all the stakeholders of a building ecosystem so that they can work together and create a building that is holistic for at the end, the occupants of the building. So that was some very interesting points that we came across in this conversation. Let me now invite Mr. Remel Behel, Head for Enterprise Business, Havells India Limited. Remel Behel had been listening to the entire conversation and the presentation, and he is here to summarize what we just heard and to present the thank you note for the day. Let me give a brief introduction of Mr. Remel Behel. He's the Head for Enterprise Business and engages with architects, consultants, interior designers, industry, government, infrastructure, and key commercial project stakeholders. He's an electrical engineer with 26 years of experience in electrical industry and expertise in enterprise solutions, business development, strategic planning, and sales. Mr. Behel, you had been listening to this entire conversation. Over to you now.
Thanks, Sapna. Good afternoon, all. On behalf of Havells, it's an honor and privilege for me to propose a vote of thanks for our honored guest, architect Manit Rastogi from Morphogenesis. Really, the discussion was really an eye-opener. Your emphasis on sustainable design with focus on combining heritage and culture along with green technology is unique. And your thoughts on soul, sustainable, optimized, unique, livable designs, I think is very relevant in today's context. Each one of your projects, whether it is the Pearl Academy at Jaipur and the use of, the concept of a step well, is actually the use of tradition along with technology. And each one of your projects, whether it was the British School or the Wipro campus or the ITC mixed use campus, is a unique experience, and it is also providing an architectural experience which is unheard of in today's context. So we at Havells are also committed to providing safe, renewable, and efficient solutions for such prestigious projects. And we also imbibe the philosophy of working in a close working collaboration with our clients, partners, and stakeholders to together achieve a successful and sustainable outcome. I'd like to thank all the honorable participants who have taken time out for participating in this ADEX series. And also would like to thank the organizing team from Havells as well as from ADEX for all their efforts. Thank you, Architect Rastogi, and have a great day ahead. Thank you very much.
Thank you.
Thanks, Mr. Behel, for summing up the session and expressing that note of appreciation and sincere thanks. Thanks, Mr. Vivek Yadav, as well, for being part of this session and sharing your views, as solution provider. Once again, I thank our speaker of the day, Architect Manit Rastogi, founding partner, Morphogenesis, for sharing those, pearls of wisdom with us and, sharing his knowledge with the Indian and global design fraternity. And most of all, our sincere thanks to our awesome audience for being here, sharing their time, sending in their questions. So do keep watching this space. We bring to you yet another acclaimed design expert next time. Till then, thanks and goodbye. Thanks, Architect Manit Rastogi. Thanks, Vivek Yadav. Thank you for being here today with us.
Thank you. Thank you, everyone.
Thank you.
Thank you, Vivek. Thank you, Ramal. Thank you, Sapna.
Thank you.